Hello, students. Today we'll study just a minute, lecture 6. Now here we'll study ultrasound, sonic boom and supersonic aircraft. Right? Now first, whatever we want to discuss, that is, what is the audible range? Now, if this one is at scale 20 hertz to 20 kilohertz, this much is the audible range. This is the, I'm writing here, audible range, right? That means if the frequency of the sound is greater than equal to 20 hertz and less than equal to 20 kilohertz, then we can hear it, right? And 20 kilohertz, that means 20 kilohertz, that means it is 20,000 hertz. Clear? So what is the range of audible frequency? Audible frequency is that 20 hertz to 20 kilohertz. And already we have studied another thing, that if in a laboratory we are testing this, then the 20 hertz may be 12 hertz also. But that is the in laboratory things. Where there will be no noise, no sound other than your uttered sound, there will be no sound. But here, generally that audible range is 20 hertz to 20 kilohertz or 20 hertz to 20,000 hertz. Fine. Now, beyond this, that means the frequency that is less than 20 hertz, that is called infrasonic sound. That is called infrasonic sound. So the frequency, the sound that has the frequency less than 20 hertz, that is called what? That is called infrasonic sound. That is called infrasonic sound. And the frequency that is greater than 20 kilohertz or 20,000 hertz, that is called ultrasonic sound. That is called ultrasonic sound. What it is called? Ultrasonic sound. Right? So what we have studied in this slide, first the audible frequency range, that is 20 hertz to 20 kilohertz. Then if the frequency of the sound wave that is less than 20 hertz, then it will be called infrasonic sound. And if it is the frequency is greater than 20 kilohertz, then we'll tell that it is ultrasonic sound. It is ultrasonic sound. But our audible range, the frequency range, whatever we can hear, that is 20 hertz to 20 kilohertz or 20,000 hertz. Clear? Now, what is ultrasound? Sound waves, already we know one definition. The sound wave frequency, if it is greater than 20,000 hertz, then it is called ultrasound. Okay. So this is ultrasound. That means what? Sound waves with frequency higher than upper audible limit of human hearing are called ultrasound. And the limit varies from person to person, but it is approximately, on an average, it is 20,000 hertz. And the physical properties of ultrasound are similar to the normal audible sound. And this ultrasound, we have several applications. We have, just a minute. We have several applications. We have several applications like this. We can use for USG, ultrasonography, and other also several applications are there. I will discuss this in this lecture. Before that, we are just saying in the which fields we are using this. This type of sound we are using for navigation. So for navigation, for medicine purpose also, for imaging, for cleaning, for mixing, for communication. This frequency is also used for communication and testing, and there are a huge applications of this. Now, here, whatever the applications we'll discuss one by one. First is the cleaning. This is a device which use the ultrasonic cleaning. Now, in objects which part that are difficult to reach, for example, spiral tubes, electronic components, process of ultrasonic cleaning is used. Suppose spiral tubes, where how you can clean it. At that time, if you are using ultrasonic cleaning, you can do it better. So object that is dipped in a solution of suitable cleaning material and ultrasonic waves are passed into it. What we are doing? We are just dipping the object in the solution that is suitable for cleaning that object, because the object material also need to be considered, and ultrasonic waves that are passed into it, and as a result the high frequency waves are generated that cause the dirt and grease to detach from the surface. The dirt and grease to detach from the surface. So how we are cleaning this? The object, whatever we need to clean, that is not possible to clean in normal way. At that time, that object, what we are doing, we are dipping it in the solution that is favorable or suitable for that material, and then we are using the ultrasonic waves that will be passed into it. Now whenever it will pass into it, then high frequency waves that are generated, and that will cause the dirt and grease whatever has been attached here, that will be detached from the surface. So the cleaning process is complete at that time. Generally, in case of our electronic components, they are so tiny that we cannot clean them properly, and cleaning is very important for that. Whenever spiral tubes are there, at that time we are using ultrasonic cleaning. Ultrasonic cleaning. Is it okay? I think all of you understood this ultrasonic cleaning. So again, I'm just in a gist, I'm saying you have one container there where you have to keep the object, and you have to dip the object in a solution, but the solution should be favorable or suitable for the object. The solution should be favorable, because if there is some reactions, at that time it will not work. Then we are passing the ultrasonic waves, so high frequency will be generated, and this high frequency, due to this high frequency, whatever the dirt and grease you have around the surface of the object, that will be detached and it will be cleaned. Okay, so that is the cleaning or using ultrasonic object. Now detecting the cracks. Detecting the cracks. Here, in detecting the crack, whatever we are doing, in the metallic components that are used for construction of high-rise structures such as building and bridges, we are using to detect the cracks. Now they generate and display an ultrasonic waveform that are interpreted by a trained operator, often the aid of analysis of software, to locate and categorize the flaws in the test pipes. Suppose we are using here some long pipe here, and in the high-rise building, you have to detect in the high-rise building at the time of construction or bridges also, you have to detect the crack. And the crack is so that is not visible with open eye. So what we have to do at that time to check the condition of the bridge is okay or not, that is very important, because the condition of the bridge, that is related with the several lives of several persons, right? So whatever we have to do, we have to detect if there is any crack or not, and according to that we have to take the measures also. So what we are doing, the ultrasonic waveforms that will be passed, and then you can see that that will be interpreted or that will be analyzed by the analyzers, and they are using the software to do it. Then they will find out what will be the crack and where is the crack, how much crack is there, everything they can detect, and after that the authority they can take the measures. Okay, so this is the detection of the cracks. That is very very important to detect the cracks in case of our bridge. So high frequency sound waves that reflect from the cracks or flaws, then this echo pattern will be analyzed. It will be displayed by the software and it will be analyzed and recorded in a portable instrument. After detection, if there will be any crack, at that time the measures should be taken. So the echo pattern from the test piece may then be compared to the patterns from this calibration standards to determine the condition, right? That means what? If I am getting some pattern here, I have to compare it with the pattern of the normal case. That means some pipe that has that does not have that do not have any crack. So we know this is the ideal pattern. So if there is any variation of your pattern here, variation over the pattern, at that time you can see that yes, this is a CAC and it cannot be considered. So here another application, that is the echocardiography. If someone is telling and to the doctor that I have some pain, I have some pain in my heart, so or I have some pain in my left side, upper left side. So what they will do, sometimes they are giving the medicines, or sometimes what they are doing, they are prescribing echocardiogram, ECG. They were prescribing ECG or echocardiography also they are prescribing. So here you can see that the process of echocardiography, the ultrasonic waves are used to form an image of the heart, right? ECG, at that time we are creating the waveforms, but here, and we are detecting there is any problem or not by evaluation the waveforms. But here we need some image. Suppose there is a person who have a severe pain in the heart, in the portion, upper portion. So at that time doctor prescribed that echocardiogram, that doctor prescribed echocardiogram. So at that time what he will do, echocardiogram. Okay, you do it and then you come to me with the report. So at that time what they will do, they will play some uh, sensors, and after that they will pick up some picture or image. And how it can happen, actually using the ultrasound, ultrasonic waves will be passed, and these ultrasonic waves, they are used to form the image. This is the image. They are using this to form the image of the heart using the reflection, and then detecting of these waves from various parts will take, and the doctors, they are analyzing this picture. After that they will detect what is the exact problem in that person, in the patient. Okay, so this is echocardiography. Next is the ultrasonography. Suppose you have some pain in your stomach and repeatedly there is some pain, or some lady, or a lady, or a lady, she is pregnant. At that time this ultrasonography that is required to find out what you have in your stomach, upper abdomen. Actually they are saying upper abdomen or lower abdomen, they are scanning this thing. You have some pain in your lower abdomen, it may be in your lower abdomen or upper abdomen. So that scanning is required and the image is required. At that time they will prescribe ultrasonography. What is here medical ultrasound that diagnostic images we are taking here. Now it is used for imaging of internal body structures such as muscles, joints, internal organs. Ultrasonic images are known as sonograms. Known as sonograms. Now in this picture you can see that after ultrasound there is some mass here. There is some mass here, right? So this mass will be analyzed with the use of the software. Then the image actually has been taken by using the reflection of ultrasonic, using the ultrasonic wave. Okay, ultrasonic wave we are sending, and then it will be reflected back, so it will create the image, and that image will be analyzed. If there is any mass, there will be any mass, at that time it will be analyzed, and the dimensions also it can be detected after the analysis of the image, right? So this is the ultrasonography, where we are using the ultrasonic wave, where we are using ultrasonic wave. Now, in this process, what we are doing, as I have already discussed, the pulse of ultrasounds are sent to the tissue using a probe, using a probe, and the sound echoes of the tissue, where different tissue reflect sound varying in degrees, and these echoes are recorded and displaying the image, and this image will be analyzed. This image will be analyzed by software, or sometimes the doctors they are seeing the image plate, and they can detect that yes, there is some problem or not. Or in case of pregnant women, they are saying that the child, or the child that is okay or not inside the abdomen. Okay, inside the abdomen. So here the another application, that is the sonic boom. That is sonic boom. Now sonic boom, what is this? It is a sound associated with the shock waves created when an object, sorry, when an object, okay, when an object, it is a sound that associated with shock wave created when an object travels through the air faster than the speed of sound. That is the sonic boom. Sonic boom, that is nothing but one sound that has the frequency that is greater than 20 kilohertz. And sonic booms generate enormous amounts of sound energy and sounding similar to an explosion or a thunderclap to the human ear. Now in this picture you can see that sonic boom, and it has been recorded, and this sonic boom, here you can see that how much is the intensity is here. Okay, so the sonic boom, that is associated with the shock wave created when an object travels through the air faster than the speed of the sound, right? And it will just look like explosion or thunderclap. So here, in case of our thunderclap, that is incredibly loud, produce the levels of 100 to 120 dB, 120 dBA, that equivalent standing near a jet during the takeoff. Jet that will also produce the sound at the time of takeoff. So this also, the sonic boom, that also creates the sound like the thunderclap, where thunderclap that will produce the sound that is 100 to 120 dB. Now the crack of the supersonic bullet passing overhead, or the crack of the bullwhip, are examples of the sonic boom in miniature form, right? So sonic boom, that means there is explosion or the sound, that sound frequency is greater than 20 kilohertz, and it is very high, and the primary unit of measurement of the sound is the what? Decibel or dB. And here How much dB will be here? Thunderclap, it has 100 to 120 dBA, whereas the sonic boom also creates this much of sound, and that looks like the jet sound of the jets when it will take off. So sonic booms due to large supersonic aircraft can be particularly loud, and here that will awaken the people and may cause minor damage to some structures also. And this led to prohibition of routine of supersonic flights over land. Supersonic flight is not acceptable here. Now they cannot be completely prevented. Research suggests that we should be careful of shaping the vehicle so that the sound is a little bit less. So here you can see that when the aircraft passes through the air, it creates a series of pressure waves in front of the aircraft and behind it, similar to the bow and stern waves created by a boat. So the aircraft also, whenever it passes, the aircraft also, whenever it passes through the air, just a minute, whenever it passes through the air, you can create the series of pressure waves in front of the aircraft and behind it also. And these waves travel at its speed of sound, and as the speed of object increases, the waves are forced together or compressed because they cannot get out each other's way quickly enough. Here you can see the sound, how much is the sound intensity there. Here you can see. Okay, so here if merging, if all the sounds that will merge into a single shock wave which travels at its speed of sound, then a critical speed known as Mach 1. This is approximately 1235 km per hour. Can you imagine how much is that? In case of air, we have only 330 meter per second. But here now, the speed of the sound becomes 1235 km per hour. That means 767 meter per hour. 767 meter per hour at sea level and 20 degrees centigrade. So this is called Mach 1. This critical speed called Mach 1. So in smooth flight, the shock wave starts at the nose of the aircraft and it ends at the tail. So here you can see that different radial directions around the aircraft direction of the travel are equivalent. The shock wave forms a Mach cone. It has been shown here with the aircraft at its tip. Here it is the alpha angle, and this one is the Mach is greater than 1. This is Mach equal to 1, and this is the waveform of Mach is less than 1. Here you can see this position. This is the aircraft, right? The red one is the aircraft, and you can see that here if Mach is less than 1, at that time the sound is ejecting from the front and tail also. Here only tail also. Here you can see the Mach is greater than 1. These three conditions it has been given here. So sine alpha, that equals to V sound by V object. It is the ratio of the V sound by V object, where alpha is the half angle between the direction of the flight and the shock wave. Here you can see alpha. This is your alpha, and alpha is nothing but the angle between the direction of the flight and the shock wave. Sorry. So it is inverse of Mach, and Mach is the V object by V sound. So Mach plane's Mach number is the 1 by FA. Thus, faster the plane travels, the finer and more pointed this cone is. Okay. So there is a rise in pressure at the nose, decreasing steadily to a negative pressure at the tail, followed by a sudden return to normal pressure. So this overpressure profile, that is known as N wave because of its shape. N wave because of its shape. And the boom is experienced when there is a sudden change in pressure. Therefore, the N wave causes two booms. One when initial pressure rise reaches an observer, another when the pressure returns to normal. Okay, so the boom, sonic boom, that will create two waves. And here it has been described that the sonic boom that will be created, but there is a term that is called the boom carpet. That is called the boom carpet. Now, since the boom is being generated continually, as long as the aircraft is supersonic, it fills out a narrow path on the ground following the aircraft's flight path. At that time, a bit like an unrolling red carpet will be seen, and hence this is known as the boom carpet, and its width depends on the altitude of the aircraft. And the distance from the point on the ground where the boom is heard to the aircraft depends on the altitude and the alpha and the angle alpha. Now the supersonic aircraft. Supersonic aircraft, these are any aircraft that can achieve the flight faster than Mach 1. Mach 1, that means we have told you 1235 km per hour. This much speed. So supersonic aircraft, that means the aircraft will achieve that speed that is greater than Mach 1, that which is supersonic, and supersonic includes that speeds up to 5 times Mach than the speed of the sound, or Mach 5. It is Mach 5. And top mileage per hour of a supersonic aircraft. Here you can see the supersonic aircraft. The structure is also very important. So supersonic aircraft normally ranges anywhere between 700 to 1500 miles per hour. This is the supersonic aircraft. And typically most aircraft do not exit 1500 millimeter per hour. That means 2414 kilometer per hour. It will not go beyond that thing. And supersonic variations of the supersonic aircraft, there are so many variations, so many models also, but this engineering, that aerodynamics engineering, that will do more better thing to reduce the sound also. And other model use the efficiency and power of the thruster to allow a less aerodynamic model to achieve the great speed. Thank you. Up to this much today.